Hello, my name is Sweetness, and in this tutorial I'm going to show you how you can run a shader immediately instead of relying on a custom scene extension. This will be useful for offloading any kind of work onto the GPU, especially for any editor tools. For real-time usage though, you are probably better off creating scene view extensions and then just gating the work that needs to be done. But it's not like it can't be done this way. For this example, I'm working off of the custom shader tutorial code where everything turns into grayscale except for the color we choose. However, in this tutorial, instead of using a scene view extension, I've created an actor that has a scene capture component, which we then use to take what is effectively a screenshot and perform the shader on the screenshot. The result is then stored in a render target asset. There is also some asset creation involved that I won't go over in this video as it's outside the scope of the tutorial, but the code is there and you'll be able to see how you can create a render target and or update it with new settings. Link to the repo is in the description. I'm now going to start with the shader and then work our way back. At the top, we have a macro and then some new input variables. I control the thresholding for the saturation mask. Then we just use a single color texture. Fundamentally, the shader still works the same as in the custom shader tutorial. However, instead of using an environment variable or a macro to choose between unlit and lit, we just get the right texture CPU side instead. This is because when working in immediate mode, you can't simply get all the buffers used to get the colors like in the custom shader tutorial, but we can still get data out of the scene capture component. And then in the shader itself, it's all loaded and processed as normal. Then we have the debug output macro. If it's enabled, we output the mask for where will be color or grayscale. If it's false, we output the actual result with whatever parts are grayscale and then whatever parts are color, and output the actual result. Moving to the global shader class, the parameters have been changed to this just to reflect what's in the shader. And then the global shader class itself, you can see we drive the macro in the shader with a shader permutation. You can see how permutations are set up and work in a previous tutorial. With the shader side of things covered, let's move on to the actor where the immediate rendering will be done. In our header, we have our function that will be run in the editor to run the shader, and then a bunch of variables. These are ones we set to impact the output. These are just visible only, just the results. At the very bottom of the class, we have some editor-only functions. We have a function where we get or create the output render target asset, and then a function for saving the same asset. I won't be going over these functions in the tutorial. Moving on to the implementation, above our constructor at the very top, these are just some hard-coded asset locations that we'll use for getting and saving the render target assets. And then we have the constructor where we create the necessary components. So that's just our root scene component and then our actual scene capture component. Our begin play and our tick functions are empty as we're not using those. And then for the actual function, we first make sure that it's editor only. This is because we're just targeting this functionality as editor only, but you could remove this if you wanted to. However, if you do, make sure that you're not using gedit as that has a dependency on Unreal Ed. Moving on, we have some checks so we don't have any problems, and the first thing we then do is get the assets. These just get or create our render target assets, and then once our assets are sorted, we do the scene capture. We update the capture position, set the output target, the capture source, and start the capture, followed by flushing the render commands so that we execute any pending render passes that are set up when the capture is called. Next, we get the underlying resources and texture RHIs for the render targets. Make sure to use the game thread variant of the get render target resource function since we are in the game thread. Now, these variables are created so that we can pass them into the lambda below, and all it is just the values from our class itself. And here is the main part, the Enqueue render command macro. In here, we create a new graph builder using the input RHI command list. Then we create our render targets, adding them to the render target pool, and then register them. After that, we get our global shader map. And like normal, we set up our shader parameters, then the shader permutation, and then we just do a full screen pass. Once that is done, we call the execute function on the graph builder. And then outside of that, after the commands are enqueued, we flush the render commands again. And that is pretty much it. If you found this tutorial helpful, please give it a thumbs up. Let me know in the comments below. And as always, thank you for watching.